videos to go over the combination. So the definition of combination is a subset of a set S that is a combination of elements of S, and you can think of a combination as being k things chosen from the set of S, which itself has n elements. So the difference between permutation and combination is that the order doesn't really matter, right? So if you try to make a group of 5 people out of 12, no matter how you pick those people, that is not going to be, the order doesn't really matter because you're going to have a group of 5. But if you think of NBA draft, right? Of course the order matters. If you get first pick, that means you're really, really good. If you got picked 25 times, 25th, then maybe you might want to, I understand you're pretty good because you got picked in draft, but maybe you might want to think about the second career because ... right? So that's the difference between combinations and permutation. And we have some notations like C and small 9 on the left bottom, and let's say 5 on the right bottom. This means that you're picking 5, you're making groups of 5 out of 9 people, right? For example. This means that, so you have 9 times 8 times 7 times, well, you know what? Let's just put 3, right? So you have 9 times 8 times 7, for example. So you're making a group of 3 out of 9 people, right? So let's say we have, we picked Anna, Brendan, and Carol, for example, right? That's 9 times 8 times 7. Since the order matters for the permutation, well, this is just simply permutation, right? That's the permutation, but this means that ABC is different from ACB and BAC, BCA, CAB, and a CBA. So you're counting if 9 times 8 times 7. These are all different because this is a permutation. But in a combination, these are all the same group. We don't care how they lined up. So we are actually counting 6 times per one permutation. So we have to divide 9 times 8 times 7 by 6, which is 9 times 8 times 7 all over 3 times 2 times 1. Do you start seeing it? So if you generalize, and if you have a combination of n choose k, right? We just simply say n choose k. Then we have n times n minus 1 times n minus 2 times ... all the way down to n minus k plus 1, right? 7 is more than k plus 1, right? Or you just can simply say permutation of n choose k, permutation of k object taken from group of n, divided by 3 times 2 times 1, which is this number, so it should be k factorial. Is that right? Is that right? Now we know what the p permutation of k object taken from group of n is from the previous videos. We know that that's n factorial over n minus k factorial. So I'm going to replace that p permutation part. So the combination will be equal to n factorial divided by n minus k factorial all over k factorial, right? So that gives you that n factorial divided by n minus k factorial divided by k factorial, which is multiplied by 1 over k factorial. Simply speaking, that is n factorial over k factorial times n minus k factorial. So that is the theorem 4.2. That is equal to combination of n choose k. Okay?